Hello grade 11s. So let's just continue on getting to know how to use the formula. So again, I encourage you to write it down on a piece of paper next to you so get used to it. I'm just using it from my head. So if I try to look at this quadratic and try to factorize it, there's no way that I can solve it or factorize it and then solve it using grade 10 methods. You can try, but you'll see that the 2 doesn't break down into factors that can add up to plus 10. So we have to use the formula here. But the formula will work in any scenario regardless, but just bear that in mind. So now, if I have x equals, well, what is my a, b, and c? Well, my a is going to be 1, my b is going to be 10, and my c is going to be minus 2. And so it's merely a matter of substitution. So I go minus 10 plus minus, those are the two roots in the equation, b squared, so 10 squared, minus 4 times 1 times minus 2, over, what do I have? 2a, so 2 times 1. So now in my next step, what I'm going to do is I'm going to break apart the roots into their two parts, or there are two when they start, but we're going to write them separately. And then I'm going to calculate what delta is, the thing inside the square root bracket. And I get 10 squared, which is 100, and then minus 4 times 1 times minus 2, that is going to be, so that's going to be 8, positive 8. And so what I'm going to have inside my bracket is going to be 100 plus 8, which is 108. And that is going to all be over 2. Or I could have minus 10 minus the square root of 108. Notice how I'm not having to compute it again because I know it's the same, and again it's over 2. And these are my answers. Now I'm not using a calculator right now, but I could put this into my calculator and find what it is. And what you'll find is that delta is not a perfect square in this case. And so if you get the decimal expansions, you'll see that there's no repeated pattern, and in fact it goes on forever. On your calculator, it will stop after 10 digits, but that's only because your calculator doesn't go on forever. So in fact, we look at the solutions to this equation, and they are exactly like this. All that I have is the fact that it is going to be an irrational number that is my root, or my roots. Okay, let's move on to the next one. So, if I move on to another one, let's look at something like this. How would we solve this? Same idea as before. What I have is I've got A is going to be equal to 1, B is going to be equal to 5, and C is going to be equal to 9. So, as I find my solutions, I'm going to get X is minus 5 plus minus b squared, which is 5 squared, minus 4 times 1 times 9 over 2 times 5. I lie, because it's not 2b, it's 2a, so in fact 2 times 1. Let's do the second thing, which is splitting it. Minus 5, let's go plus. Now what's delta going to be? So this is interesting because now I've got 25 and minus 4 times 9, so I've actually got minus 36 over 2. Or x is going to be equal to minus 5. Now it's going to be minus 25 minus 36 over 2. So let's look at this more carefully because something is a bit different this time. So what we have is we've got minus 5 plus, and then 25 minus 36 is just going to be what? Well, I've got 5, I've got minus 11, or I've got x is minus 5 minus square root minus 11 over 2. Now this is very interesting because we're saying the roots of this equation, or the solutions to this equation, have inside of them a square root and the square root of a negative number. So it turns out that in fact not all quadratic equations have solutions in the real numbers. In fact, we would call these two numbers non-real numbers because of the fact that there is a negative inside the square root. And so what we find is that, again, delta is being very helpful at showing us what is the nature of the root that is the solution to the equation. Once we have a negative inside a square root, they're going to be non-real roots. And what's more than that, we're actually going to say there's no solution because of the non-real roots. Or there's actually no solution in the real numbers, and that's our concern at school level. So, I would probably say the more correct way to say it is there are no non-real roots, therefore there's no solution. And essentially, we need to be aware of the fact that this can happen, and not every quadratic will have real root solutions. Okay, we have introduced you to quadratic equations, completing the square, the formula, and how to use the formula. And if you have felt unsure at any time, I really encourage you to watch the video again. There's nothing like repetition to help you understand something, and I really encourage you to have a calculator with you and to have a piece of paper and write things down as you go through these videos. Alright, so I hope they were helpful.